All right, y'all. So let's look at electron configurations, specifically when we're dealing with ions, anything that has a positive or negative charge. So a quick reminder that when we look at this group, this is generally the s orbital. This group is our d, and this group is our p. And our d orbitals actually start here at 3d, 4d, 5d, 6d, and I'll actually come down here for f. And this is actually going to be 4f and 5f. So when we're looking at electron configurations, let's just be a little mindful of that. So before we even start talking about ions, if I, for example, had a question where I say, I lost 2 crayons, now I have 22 crayons. How many did I have? If I asked you all this question, you'd be pretty confident in your answer of possibly 24, because if I started with 24 crayons, then I subtracted 2, now I have 22, bam. So you'd be pretty confident in that answer. This is the same concept behind the ion problems. If now I say, if I lose 2 electrons and my configuration is, let's go ahead and write out the configuration for 22 electrons, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. And we add up all the electrons, 2, 4, 10, 12, 18, 20, 22. So now we have 22 electrons. Knowing that we originally lost 2 electrons means we originally had 24 electrons to start with. Knowing I had 24 electrons to start with, looking at a neutral atom, we know that 24 electrons is going to refer to 24 protons, and 24 protons is an atomic number of 24. So we know we'd be dealing with chromium, Cr. So that's the basic concept behind these problems where I'm asking you about ions. I got a little tricky here and there, I know, but one of those tricks, but it was also a hint, is I would say I lose 2 electrons to get a -2 charge. This just confirms that the loss of 2 electrons, positive 2 charge. This just confirms that the loss of those 2 electrons meant that we went from a neutral atom to an ion. And that's so important because you can only say the protons equal the electrons in a neutral atom. So that's kind of where we go. So let's do one more example. I'm going to say, if I gain 3 electrons to become a +3 ion, and my configuration is, I'll just go ahead and just keep writing until I feel like I want to stop. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d7. Let's say 47. All right. So just like before, I'm going to first go ahead and count all my electrons. I'm going to use screen this time. 2, 4, 10, 12, 18, 20, 30, 36, 38, 45. So that's really quickly 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 6 plus 2 plus 7. Let me just add that one up real quick. I'm going to try and do in groups of 10. That's 10. That's 10. This is 10. So that's going to be 30. This is 8. So that's 38 plus 7. Yeah, 45 electrons in total. So that's our new configuration, 45 electrons. But that's after we gained 3. So if 45 after we gain 3, so whatever our original amount plus 3 equals 45, then we know our original amount is just equal to 42 electrons. Again, because it's a plus, oh, whoops. No one caught me, which I say having no one to talk back to me. If we gain 3 electrons, it's a minus 3 ion. So knowing our original amount is 42 electrons, and it became a minus 3 ion, which means it was neutral to begin with, then we have 42 protons, which go into element 42. Oh, right under chromium, molybdenum, MO. All right, so that's kind of how you do that. Good luck on your corrections, and thank you.